Next, a liquid occupies half of a vessel at a particular temperature. Then the volume of the unoccupied part remains constant at all temperatures. If alpha and gamma are the quotient of linear and real expansion of vessel, then so of all very important is this particular thing, unoccupied part. The volume of unoccupied part remains constant at all temperatures. So based on this data, we should find out the required relation between gamma by alpha has to be found out. Half of a vessel occupies half of a vessel. So how do the basically suppose if this is the half of is occupied. We can assume this liquid will fill up half of the vessel. Exactly, you can see it. Half of it is present. So here the initial volume of liquid, let it be VL. Volume of solid, let it be VS. This is a vessel. Then I'll rise the temperature. I'll rise the temperature. Both liquid as well as solid, both will expand. The unoccupied volume remains constant. So now where I have to show the liquid? Liquid I have to show it somewhere here. This will be the liquid. So we have expanded, liquid expanded, solid, both liquid as well as vessel, both expanded here. This is at T2 degrees Celsius. We are going to supply heat. Then because of heat supplied, first the solid will expand, then liquid will expand, and finally this is the thing. The unoccupied part is telling. So this is the unoccupied part. And this part should remain same. This volume should be equal to this volume. I think it can happen. I'll write this unoccupied part, let it be delta V. So now the new volume of the liquid is how much? VL dash. New volume of solid is VS dash. This unoccupied part remains as it is, will not change. Delta V naught, all delta V naught. About to analyze this, we have rising temperature. T2 degrees Celsius greater than T1 degrees Celsius. So what is actually this? This is the unoccupied part, and how much it is? Half it is. So what is the initial volume of the liquid will be equal to half of the volume. When I supply heat, liquid and solid vessel as well as liquid both will expand. Then what was this volume? It has to remain same. It's not telling half, not like that. This unoccupied part should be as it is here. Okay, now this is so now what we do is like we will write the equation. So initially, what is the volume of the what was the initial volume of the solid? Vs minus Vl should be equal to Vs by 2, which is equal to delta V naught. Then finally, Vs dash minus Vl dash should also be equal to delta V naught, which is equal to Vs by 2. What is Vs dash? We'll expand it. That should be equal to Vs 1 plus gamma delta T, and VL will be VL dash will be 1 plus, I'll write next term here, 1 plus gamma L delta T. This should be equal to Vs by 2. So why delta V naught Why you are writing delta V naught equal to Vs by 2? Because what was the initial unoccupied part will be half of the volume. Now also it has to remain same. So this should be equal to Vs. What was the initial volume of the liquid will be Vs by 2. From here, initial volume of the liquid, if you solve it, it will be like this. So what is the initial volume of the liquid? That should be equal to how much? Should be equal to Vs by 2. 1 plus gamma L delta T Vs by 2. So Vs I think will finally what we get here, gamma S equal to gamma L by 2. So now what is we want the quotient of linear. So gamma S will become 3 alpha S. So alpha S equal to gamma L by 6. So he's asking the ratio gamma L by alpha S should be equal to 6. This should be our answer. He's asking to get the ratio. Requesting all students to please subscribe, like, and comment on our channel so that we can survive. Okay. Okay, this is our answer. So for my channel to grow and survival, definitely it all depends upon your support. Without your support, I'm not in this position. So all watching this video, please do subscribe, like, comment, share to your friends. Let it get everyone benefited with this, the free knowledge available. Okay, fine. So these are the some simple diagram based question. So sir, how to draw the diagram? Diagram is what you should able to imagine a vessel half filled, unoccupied. When you supply heat like this, the vessel will expand. Even the liquid will also expand, but unoccupied remains same.